Good morning, good morning, good morning. We're back. I, I am strongly considering doing this test on Blackboard so we can optimize class time and figure out a Blackboard time that'll work. And okay, have you done tests on Blackboard? Everybody, we did so many of them during the lockdowns that we had everybody kind of learned how to do it. And the hard part about doing them is you have to import the test. You have to create the test on Blackboard, and it's a lot of copy and paste. So it's kind of labor. My more tech abled colleagues are able to somehow do that more magically than I can. But long story short, I'm thinking of doing it that way. And that way we can figure it out. And it's possible maybe that Monday before, like the third, before you guys just because you're not the only people who are disappearing that week. Okay, or if not, is it harder? I take it once you get there, you're pretty busy down in this competition you're going to. Correct? So you wouldn't have time to, God heaven forbid, do schoolwork. You probably won't go to the beach at all. Maybe once. Sure. Also, frog in my throat. You drive up to Jacksonville. Maybe you can see my grandkids. Even get you on the naval base. You can tour the ship. Okay, moving on. So maybe I'll do that on the third, and I'll open a window. And basically, the way that you do them online on Blackboard like that is effectively it's time oriented. So once I can open a window for I can open a window for 5 hours, but once you start, even you can click back and forth and check answers. Once you complete it and submit it, you're done. Happy dance, and you see right away how well or how not well you did. Just saying. Okay. The single most important thing with this is to have a reliable connection, internet wise, wherever that is. So if you're on campus, that's fine. If you're at home, that's wherever you are. Make sure that's reliable because it's very annoying when it isn't. And what I do is I just stay and I just because I have my phone with me all the time anyway, is you just effectively text me. We did this before, didn't we? Do that with the final and A&P for those guys. That yeah, same operating procedure. All right, that's my plan because we have a lot of stuff I do want to get done in lecture, and test days to me to a certain extent take that away. I don't mind if you're not there, but when you're doing that, I can be sitting there making up a lecture and sending it to you at the same time. Because a lot of this is me just going over stuff. And so could not do that we had too much going on in our house on Friday. And then I was out of the house. So basically I didn't do that till Saturday morning. And there was no soccer this weekend anyway. The Premier League is on break, it's international break, which makes for dull weekends for me. I like soccer.
Is the final gonna be like it was for anatomy last?
Quite possibly. Not for you. For the nice students, not for the unpleasant students who annoy me. Your cadre is not here. See, I'm starting to notice these things. All right, everybody out there in virtual land, I'm done annoying everybody. Here we go. So I'm going to jump around a little bit because I use both of these PowerPoints, but I'll start with the Callan one. And I had ended with this. If you didn't get a chance to listen, I completed the antibiotics. And you've got to look for points. Okay, I'll give you one because I'm nice. I talked about tetracyclines. They cause your teeth basically to rot, baby teeth to rot. That's why we don't give them to pre-adolescent children. That's an important point. Okay. The categories are important points. So go back and listen to. I talked a lot about combination sulfa drugs. They're important. I gave you a pecking order that we typically use for MRSA. In a lot of places, you have to document before you go to vancomycin. So these are all interesting things to look at. Depends on the facility. Every facility has different rules with regard to those types of. So looking for things like that, particularly if from a nursing perspective, for many of you, being aware of the potential side effects and what to look for when you go in and evaluate a patient, when you check on them. I mean, just say, okay, So in the back of my mind, I know this person is on, on gentamicin, which we use for Pseudomonas aeruginosa. It's an aminoglycoside. So your kidney tests are one thing to look at, but if you start to hear the hearing abnormalities, just little things like that, because typically you see them every shift or for X amount of time, and you notice from day to day, subtle things. And particularly with older patients, sometimes they have difficulty hearing anyway, so it just depends on the situation. So I finished that, and I told you about antifungals are all about one thing: ergosterol synthesis. All of the agents today target that. They have some side effects because they're eukaryotic cells, and that's what we're dealing with now. We're going to deal with viruses, and viruses inhabit our cells, so that makes them a problem. So they're tough to deal with. Okay, but protozoans and fungi, and I don't really do the worms, are eukaryotic cells. And since the cells are similar to ours, when we interfere with them, inevitably they interfere with ours. So we're basically dealing with the integrity of the membrane of those organisms, and the membranes are unique because in fungi they have a sterol called ergosterol, like we have cholesterol in animal cells. So we target ergosterol. For years, we used different methods. Most of those agents were harsh. We used ones that cause diseases. Historically, one called amphotericin B, nystatin, which is still utilized today, but less so than it was. Uh, those were agents that were so harsh they either had terrible side effects or they could only be used topically. There was one historically that we used a lot of back in the 80s called griseofulvin or fulvicin. And again, that's interfering with metabolic processes of fungi that were so similar to ours. They cause autoimmune diseases in some individuals. So imagine you're coming in to treat athlete's foot and somebody's getting an autoimmune disease. I mean, you don't want to be on the business end of that lawsuit from a doctor perspective. It's just, there's a lot about that. So now with the advent of the ketoconazole groups that you will see, the allylamines and the ketoconazoles, those are agents that have a certain amount. You would use them orally, and they'll even comment on one in this PowerPoint sequence about some resistance that we're starting to see now with Candida, which is a nasty infection. So many recurrent vaginal yeast infections in thrush, which I have. Okay, and Candida is one of those things that we do see overgrowth in immunosuppressed individuals. That we're starting to see resistance to that with fluconazole or diflucan, which I think is one of the best pharmaceutical agents ever. I mean, I used a ton of it. I mean, it's one of those ones I had prescriptions already made out. I just had to sign them. Put how many refills. Boom. Okay, moving on. Be careful with prescriptions. Side note to everybody. I had a guy came in my office, two guys. One guy I was treating, I always knew he was a little sketchy. And I haven't told this story. And his buddy came in and distracted the lady who was up at the front of my desk while he was signing out. So he's talking to her through a window. He's over by the desk being discharged. He's distracted. He reached in, grabbed my prescription pen, started writing Percocets for everybody. That's oxycodone. I'm getting calls from the state about this. Oh my God. I thought he was going to testify in court. Yeah, he ended up in jail. A guy was undercover operative from the state policeman who actually went in jail to try to get close to drug dealers, eventually nabbed this guy at a pharmacy. He was trying to write, like, I had forged my name because he already knew my DEA number for prescriptions. It's like, oh my God, am I in trouble? He says, no. Because he showed me the prescriptions. I said, this is my handwriting. I showed him my handwriting. Oh my God. Be watchful of things like that. Anybody, if you're going into a medical field, be watchful. You can't possibly get stuck with any type of controlled substance stuff, and that includes a DUI. I've probably said it before, I'm going to say it again. Don't F up. Not to any of you, because it's easy. Oh, why am I preachy this morning? Because there's no soccer on. That's the problem. Bothered me. Nothing to go up and scream about. So moving on. That's the big nugget at the end of the last thing. Anti-malarial drugs are interesting. Okay, malaria is still the single largest killer in equatorial Africa. So we don't see it here because we're not dealing with mosquitoes everywhere. Okay, we're not. There's malaria in any kind of a tropical area, or rainforest and that type of stuff. But as we incur upon them, we get problems with it. Quinine alkaloids were something that we found out about when they went to dig the Panama Canal at the turn of the last century, because they were getting malaria. You're in the middle of a rainforest in Panama, okay, and they're going through that, and the natives are saying, look, here's this extract from this leaf, a quinine plant, effectively whatever plant it comes from, and magically quinine alkaloids. What they do, and I was just looking at it, and now they're a little less toxic, the quinolines, and the one that you heard about, hydroxychloroquine a lot during COVID. There was information and misinformation, and there's a little bit on both of this. The way that they work is they grab iron, which the malarial agents need to reproduce, so they sequester the iron. Is how they work. They're all different kinds of Plasmodium species, and there's a lot of effective methods to both treat them and even to use them preventatively if they still do that. And this artemisinin, which I had not heard of, is now it effectively works similar. I do not know if it's in the same category, but it works similarly with regard to iron that is there. So these are not innocent bystanders. But it depends on where you travel. But typically travel, you're a little less worried about it, as opposed to going on, let's say, a medical mission someplace where you could be. And I've had plenty of students do that type of stuff. So you have to be aware of that. The most commonly used drug is basically metronidazole. When it comes to anything but malarial agents, it's extraordinarily important because you saw them in antibiotics. They target anaerobic metabolism. Okay. Intestinal and liver diseases caused by, and this is nasty, causes something called amoebic dysentery. There's two kinds of dysentery. Shigella-based dysentery, which is horrible. That's from contaminated water supplies. When you get protozoans in the water supply, again, they're both associated with different kinds of fecal material. We do see that in this country, particularly for folks who have well water. Depending on where you live, if you're in a more rural area, it's not unusual to have a well and have a septic tank. And there can be problems associated depending on what might foul, if that septic tank is not done properly, there's a problem with it, or an animal sometimes fouls the water supply. Those are all sorts of things. So we see giardiasis is probably the most common. My kids had that when they went on they stayed with somebody had well water when my first wife and I were away at a conference. And this is second most common, in my view, sexually transmitted disease, Trichomonas vaginalis. They're protozoans. And we're going to revisit that again, certainly, in the area of sexually transmitted urinary tract-based infections. And metronidazole works for all of them because effectively they're anaerobes. It has relatively little side effects other than a headache. It's easily taught. When my kids had it, they put it into it comes as a liquid, and the pharmacy can flavor all those things with anything you want: pineapple, bubble gum, whatever float their boat. And they were little at the time that happens. I think I go on that trip. They were relatively little. I mean, 86, 87, that area. So there are other ones that you can see, even sulfonamides, which are antibiotics, tetracyclines, have some activity against them. So we don't treat as many of them here, with the exception of the Entamoeba histolytica, Giardia, and Trichomonas vaginalis seem to be the ones that are most prominent. Again, it depends on the water supply, and we're spoiled. We have, relatively speaking, you see what's happening. Which is just there's a water advisory. One came in Philadelphia recently of significance. You remember I sent you an article, okay, and the reason I sent you the article about that, and I don't know if you're using that stuff or not. So I got off the topic, but I might as well comment on it. It's what I do. I look, when I see there's a water supply is contaminated, and if it's not something from a natural disaster, but if it's something that has to do with something that fouls it, these are the kinds of things that are very apropos of this, because it spreads like crazy. If they get into a pharmaceutical, like particularly for an eye agent, people are losing eyes and going blind. Okay. And and I've probably shared it with you. My sister was upfront with this whole thing because the last time we had a monster like that was Bausch and Lomb, who had never had a problem in their entire history of making precision, and they had the number one selling contact lens solution, this Boston whatever solution that they had to pull off the market. And because of the same kind of thing, people were having to have losing eyes and going blind. Be very aware of those things. If you see them, share them with people. Doesn't mean you're going to be using that. Those are for artificial tears. Typically, older folks use those. First thing I thought of is my 96-year-old mother-in-law because I know she uses artificial tears. It wasn't those. She gets them in the dollar store. Now it's $1.25 tree because they raised it a quarter, which we're very offended by. Moving on. So the point that I'm making in a roundabout way is be wary of these things. There's still a boil water advisory in some areas of Pittsburgh, I noticed recently. So these are the kinds of things to take them seriously, please. They're part of it too, and I'm not doing them. Most of the time, the agents your immune system can attack them, and eosinophils, the white blood cells in your immune system, release particles in those granules that tend to tear apart the worms from the outside, make smaller pieces that the rest of your immune system can address. These agents typically enhance that effect if you want to paint with a broad brush. And generally, if they end up with bendazole or Quantel, this is another interesting one. Okay, typically it has limited uses. It's you heard about this during COVID. There was again a lot of misinformation about it's for horses. No, it's for people too. The dose for horses and what they call horse paste, which you can go to Tractor Supply and buy now, if you want to do that, is about 5 times as strong as the dose that you would use for humans. So people who chose not to be immunized with the COVID vaccines were using this to some successfully. I mean, there was a lot of studies that suggested it had somehow enhanced your body's ability in an unknown mechanism to fight this. There was a lot of, I understand there was a lot of misinformation during the COVID period. Everybody, here's a clue. They wanted you to get those shots. The shots were making money for a lot of people. Be clear. I'm not trying to make a comment whether it was right or it was wrong, but I'm always troubled by the vaccine manufacturers are indemnified. That's a wonderful word if you're in business. It means you can't sue them. The government will tell you, well, they wouldn't make them if they could get sued. Well, what happens if they don't work and everybody gets sick? I always have a problem with that. Own up to it. If you blank up, there should be some type of consequence for it. That's just, I'm spouting off. So always look widely at sources for information about these things, because you can often find as much on one side that says supports it and one side that's against it, and the truth typically lies somewhere. Okay, bring us to viruses. So I'm going to flip over the other PowerPoint in a second because this is not very elaborate. Very unique problems, because basically for a virus to work, it's got to enter and take over your cell, and most of its metabolic functions. We have no naturally occurring antiviral substances. They are all laboratory made. There's nothing such thing as an antiviral antibiotic. So you have to somehow address some aspect of the host metabolism. Some are effective vaccines that have stood the test of time. MMR, measles, mumps, and rubella, very, very successful. Chickenpox, very successful, with the exception of now that you effectively have the chickenpox virus in some way, shape, or form, and so you're predisposed to shingles. So there's a shingles immunization, which is effectively a modified chickenpox booster that's specific to that, which undoubtedly I had somewhere in the past. Because when you get to about age 60, it's more common. All of these things there's a lot. I'm saying I don't know if they all attest to it. The great difficulty with a lot of these, and COVID certainly is no exception, is particularly for agents that have a high tendency to mutate. Because then, just like COVID, they start pushing more and more immunizations. Oh, it changed. You better get a new one for that. Or this last one, take it twice. If it was such a good immunization, wouldn't one have done? Just me. And frankly, my issue with that vaccine for COVID, it was rushed out. It was not when you pump something out inside of about a year. It's even though the technology was there, is questionable. So there's a whole, and rather than go through these names, I'm going to take you to the other PowerPoint that are there, and I'll point out the ones that are important. Entry agents. This is the oldest category and probably the most used category, and one member of it, particularly here in the aciclovirs, is the most effective. Is I think the best category, and many of you have had perhaps some exposure with these two, Relenza and Tamiflu, which are useful but only early on in the viral process. That's one of the other things about viral medications. If you're going to try to stem it, you need to attack it early. HIV is sort of an exception. So they have very, very little about that in this particular unit that's there. So very difficult for selective toxicity because inherently you're attacking the cell. Okay, they don't have a cell wall. If you're attacking your own ribosomes, etc. So they have a lot. Some of them encode certain enzymes. Those can be targets. Okay, could be a little bit more specific. Okay, interfering with replication. That's principally these what I call lookalike or analog agents. They're only effective if you have the virus. Prevention is more on the vaccine level. So that's the big problem with antivirals. They're only effective once you're infected. Okay, and we haven't seen any of them really at this point, other than successful immunizations prevent the virus from getting a foothold, so to speak. So if you remember a little bit about viruses, when we talked about them a while ago, in really the last major unit, what do? They have to enter, which means they have to attach and adsorb. They have to uncoat. Then basically they take over. They make all of those viral particles, DNA or RNA, depending on the kind of virus. And then they begin to make more particles after they replicate their genetic material with capsids and spike proteins and any other things that are inside of them. Then they assemble them, then they release them. So those are your targets. Some of them actually, and this is where HIV comes in, they integrate. They become something called a provirus, meaning that the virus incorporates with the host cell's DNA and sort of alters the cell on a permanent basis. That's also another area that you will see. And they're giving you some sort of a laundry list here. So I'll do the same thing. These entry agents are specific now for HIV. So they're about the HIV spreading, not preventing its initial entry. That's the odd thing. So as far as we know now, very, very limited. These were some of the earliest ones. The uncoating was the most obvious one. They were called amantadine and rimantadine. We really don't use them. They had to be used. They were strictly for influenza, and the trouble is they didn't work for a very long time. They had to be used very early. The big category, nucleoside analogs. Usually the and in vir, indicating the antiviral. The first one that was utilized in the earliest days of HIV at the start of the AIDS epidemic was AZT. Resistance develops quickly. This DDL, which is an adenine thing. So these are primarily used for herpetic and HIV. Doesn't work on latent infections. So what happens inside, they incorporate, these are basically lookalikes for certain types of DNA and RNA bases. And just like sulfa drugs, they have a toxin or they have an irregularity that breaks up the assembly of either the DNA or the RNA change. Aciclovirs are been traditionally the most effective because in order for them to be active, it requires what's called a viral encoded enzyme. So the herpes virus, once it enters one of your cells, starts to make an enzyme that thankfully activates the acyclovir family. And so it only affects cells that are already infected. So it's more selectively toxic. That's the beauty of the one that most people are familiar with. It's orally active, called Valtrex. You can also get acyclovir. That one's valacyclovir. So somebody who's prone, my wife is prone to that. Yeah, probably gets one every couple of years. So you get a bottle with a couple of doses sitting around just in case. You know, you don't have to take it that often. That's there. Very, very boom, right away. So it's obviously in some people it works better than others. So there's quite a few of these. Herpes, so Valtrex really is something that's used a lot to prevent recurrences of herpes, and probably see it more so for folks who have genital herpes or frequent recurrent genital infections, to prevent those or to make them go away faster. So it prevents the recurrence, and if there is a recurrence, it makes it go away faster, and it's less likely recurrences. Those kinds of things. It's a treatment arm for someone who gets shingles, which we didn't have before. And then there's a variety of other ones that are there. Polymerase inhibitors. So again, herpes viruses use polymerases that are there, and so there's used cytomegalo is very different, and even ones that are resistant to acyclovirs. So I mean, it's not that I would ask you about that. Then this reverse transcriptase inhibitors. For the longest time, the basic arm, there was called a triple therapy. Okay, you were getting three antivirals in one pill. Those were the ones that were, once we understood what HIV was about, they included some kind of analog, a reverse transcriptase inhibitor, and a protease inhibitor. Now they've added a fourth, typically this viral entry inhibitor. Remember, if you do, that when we make viruses, they had a very, very interesting multiple areas of assembly that were there with HIV. It was the most unique, what they call transcription strategy or replication strategy. So it came in as RNA, and we used reverse transcriptase to make DNA. So one, you could stop the attachment and entry. Two, you could inhibit the reverse transcriptase. Once it was reprogrammed and started making more RNA virus, you could interfere that with the analogs. And then what happened is they made what was called a polyprotein, a long stranded protein that had protein spikes, reverse transcriptase, and capsid proteins that was all in one long chain. And what protease does is it chops it into pieces to allow those to be assembled. So that was all part of that. Now, this integration one, that's becoming very popular to prevent it becoming provirus so it doesn't infect master ones. Whether they use it separately or not, I do not know. Nearly all of the antivirals are really have the capability of targeting only about three major groups of infections. That's the unfortunate thing. Influenza, herpes infections, HIV. Not a whole lot. Okay, we're starting to develop more for hepatitis C. There is a real uptick in respiratory syncytial virus. They're starting to look more at antivirals for that. But so they're looking at ones that have either become greater problems, etc., and obviously COVID. That's part of it. So when we begin to look at that, protease inhibitors are specific to HIV because it doesn't allow the HIV. It's not about binding to the active site. The protease is really what eliminates those protein spikes, and then they can't necessarily go to it. And then lastly, and perhaps most commonly used, I think, of all of them, are these neuraminidase inhibitors. We'll look at it again when we do influenza. They have those H and N spikes. The H spikes, hemagglutinin spikes, which a lot of viruses, including COVID, have, facilitate attachment to the host cell. The neuraminidase, in this case, for influenza, facilitates release. So if we inhibit the neuraminidase from forming and not making those spikes, then it doesn't matter how many viruses are being made in the cell. If they can't get out, they're not going to affect you. So again, they have to be used early. And again, I think there's Relenza and Tamiflu. If you can get them within the first 2 to 4 days, they're still worth taking, even if it's a little late. When I had influenza, well, maybe 4 years ago or so, toward the end of the winter, I was sort of about this time of year at school. It helped a little bit. I was pretty far along before it did anything. And so this is where they look at the co-receptors, etc. And you can scroll through this if you wish. It's not a big deal. Acyclovir is, again, invalociclovir, herpes virus with little harm to healthy cells, since it's only converted by these virally encoded enzymes present only in the infected cells. Just very, very useful. And they give you a whole laundry list of these kinds of things. This is the little nugget on the fungal ones. You can go back and look at that. The ones we're using, the azoles and the allelamines, by far and away, they're all about ergosterol. Okay, these were a little bit too strong. And then a lot of these things that were part of it. And they give you a nice, and here the tables are a little bit better. So you begin to see here the malaria. Another one that is of a concern is toxoplasma, which is something you test for a lot, particularly vis-a-vis pregnant women, as a potential, because you often find it associated with cat feces. Which is why when we had 8 cats, that's right, at one point 8 cats, I had to change the kitty litter for, I can't even tell you how many years. That's a lot of kitty litter when you have 8 cats that were house cats. Just saying. All because my first wife, she got pregnant. She didn't want to have anything go wrong, but she was never able to get pregnant. So what are you going to do? Yeah, parasitic diseases, again, mostly water supply, food supply. I mean, I say it all the time. If you're interested in understanding parasitic diseases like this in worms, talk to a veterinarian. They'll be happy to talk to you about that because they deal with it all the time. Okay, so that, I'm going back to the other PowerPoint, and I might go back to this one because of what we'll be dealing with. This is about topics vis-a-vis resistance. So, yeah, this is the kind of thing, I don't know if we have to get as specific. I'll try to give you the ones you do need to know that are there. Resistance. So to me, this is the underlying theme for a lot of what this class is about. Why we are running out of agents to treat infectious disease. And most of the time, it's 2 things. It's inappropriate usage or overusage, and the other is mutations. And most of that relies on early identification and treatment, and then appropriately changing the agent till it's more specific for the problem that are there. So it's a living, if you're talking about microorganisms, effectively, even viruses mutate, even though we don't consider them living, but they have the capability of mutation, begin to tolerate an amount that would normally be inhibitory. They adapt. The genetics that we talked about, the fact that they can literally change their genotype in their own generations, like you and I magically being able to change something about us genetically. All of a sudden, I could be a great basketball player. Even I have a vertical leap of a half an inch at best. Okay. And the different kinds. Some things are inherently resistant, gram negatives, because they can't penetrate the outer membrane, versus acquired, all those plasmids, conjugation, transduction, transposition, blah, 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 blah. Look at that. As soon as they started to use penicillin therapeutically, it started. Again, the concept, they did not have the concept that this is a living population that creates generations much faster than we do. Every 20 minutes takes us 9 months under the best of circumstances. So how long does a human population, how many millennia did it take for us to evolve from whatever our ancestors were like? So we began to see it dramatically. We started to see it in the 70s, where we started to see where penicillin and substituted penicillins were used all the time. and cephalosporins were in their infancy, and we only used them because they were expensive on very severe cases. I mean, the go-to drugs were penicillin and streptomycin. Penicillin was gram-positive, streptomycin was gram-negative. And then we started to see resistance begin to develop. And so we started to see it on the large scale there. Spontaneous mutations, acquisition by all of those different horizontal or lateral transfers, slowing or stopping of the metabolism so that the microbe can't be harmed. It's just a single-celled organism that is able to alter its own metabolism so it can become more persistent and come back out under more favorable conditions. It's just remarkable. They have things called in gram negatives, you remember, maybe you don't, a thing called periplasm, which is sort of like between the outer and the inner membrane. In that area, they have proteins that are what we call efflux pumps. Antibiotic comes in, pump it out. It's like you're in a boat with a hole in it. You're bailing. Maybe you can get to shore. It's like old movies. I love that. You know that. Chromosomal drug resistance. Okay. Spontaneous mutations, changes in drug sensitivity, sometimes larger doses. And that is one of the go-to effects, depending on the toxicity. The R plasmids we had talked about, the way that they can be moved on, or transposons. Okay. So, and what happens, this is what we began to see, to sort of the rapid transition. And you'll see it in the other sequence. They talk about what happened with vancomycin. They use vancomycin for something, a common gut problem called Enterococcus faecalis a lot in hospital. One of the few uses for oral vancomycin. And then they became resistant, and it was encoded on a plasmid that got moved to staph, and now we got vancomycin resistant staphylococcus aureus, which is much more dangerous, significant problem. So all of these things, new enzymes inactivated, that's penicillinases, beta-lactamases. Uptake is decreased by mutations. It's less likely to absorb it. Eliminated, that's when we start getting into these new genetic mechanisms, okay, that are there. Binding, they actually alter the sites that it bonds to, okay. Alteration on the particular ribosome with erythromycin and clindamycin. Alternative pathways are used. Resistance to combination sulfas. Microbes deviate from their usual patterns. They find a different way to make folic acid. It's remarkable. So here, the penicillinase deactivating, chopping it off, that ring, destroying it, that are there, altering the surface, the microbe. Those, we talked about those efflux pumps somewhere inside, pumping it out, okay, altering the binding sites that are there, creating alternative pathways. So there's a lot of different things, but they're like any living thing. It's a mechanism that develops. If it's successful, then it's more likely to replicate, and then it becomes part of the population. Now it's like I said, with penicillin resistant, with staphylococcus being resistant to penicillin, it went from being 90% sensitive to 90% resistant, and then magically, now once we started to create agents like methicillin, okay, which was designed to fight that. Now, typically in a hospital, 70% or so of Staphylococcus aureus infections are MRSA type infections. And you have different categories: community acquired, which is what you're likely to get from contact with somebody else in a non hospital environment or in a sports facility. For years it was wrestling mats, but locker rooms, any type of areas, that type of thing where you can come in contact with it, even in gym equipment if it's not properly wiped down and all those things. Doesn't it bother you when somebody doesn't wipe down the equipment? They did a Seinfeld about that. I know it's early. Somebody could at least respond. I know. Just look at me strangely. So, large population exposed to drugs, like any chemical warfare, offspring, bacteria babies. and it replaces it. And they're just showing you how it is. Antibiotics kill it. Resistance survives, replicates, passes it on. So potentially, this is interesting. So this is 10 years ago. Realizing the problem that was there. We've been talking about it in my classes since I started teaching this is about 20 years ago. Nothing new under the sun until they finally publish it. It's not, this is the big issue. Unlike COVID vaccines, which pharmaceutical companies made an obscene amount of money, there's not a lot of incentive. Oh, we need something better to treat staph aureus. Are we going to make money on that? I'm not faulting the corporate sphere. Every so often, you have to understand these three words, all about money. Anybody into musical theater? Apropos of nothing? Like going to shows or did shows when you were in high school and things like that? Okay. I never got the lead, though I had a good voice at that time. I guess it had something to do with my looks. The male lead was not supposed to weigh 260 pounds. Just saying. Okay. Cabaret, one of my favorite shows. Great music. And the guy who did it on Broadway also did it in the movies and won an Academy Award, Joel Grey. I think he's still alive, about 90 years old. Just if you like Dirty Dancing, that was his daughter, Jennifer. Okay. The one song in that is "Money Makes the World Go Round." The world go round, the world go round. Money makes the world go round. It makes the world go round. Money, money, money. Liza Minnelli and he do it in the movie. It's great. YouTube it. It's great. That's the underlying theme that's here. So time-consuming and expensive to develop. It takes a product because in this country particularly, you have to file what's called an NDA, which means a new drug application. Then once that's approved, the average time is 7 to 10 years. So you see how rapidly they moved the COVID vaccine out. 7 to 10 years with 4 levels of testing. Okay, multiple levels before you get to human testing, and then 4 levels of human testing. And then it has to go through the process of being approved by the FDA. And then the companies have, ballpark, a 7 to 10 year window of exclusivity. So in order to make the money back, they probably have a window from the start to when generics can be made of about 15 to 20 years, where they have to recoup their money from that. It's an unusual system that's there. Here are just some, and I thought this was a good slide. C. diff. Anybody in the hospital is going to see it. You're going to know people have it. I've had it. Okay, and I'm sure my first wife inadvertently it came home from from when she worked at a nursing home, where she ran a nursing home basically as the weekend and evening supervisor, like many of you aspire to. She's an RN with a BSN. Okay. An instructor in a lot of those things. But if you don't, it's almost like you don't know it. You almost have to take off your clothes when you get home. Okay, because it can be all over the place. Okay. Carbapenem. If we look back on the start of antibiotics, carbapenem was a very useful drug with a lot of side effects to take care of some of those gram negatives. This is this area called extended spectrum beta lactamases that are really a troubling when we're seeing superbugs. When I started, penicillin got rid of all gonorrhea. Then they started to add, then you occasionally had a resistant form, and there was a couple of other agents. Now you have to treat gonorrhea with at least typically penicillin and cephalosporin. If it ever gets to the point where we're getting too many of those, it will run rampant. It's a common, easily spread. If you have any of it at all in an unprotected sexual contact, you're going to get it. Okay? And it goes everywhere. It just does. Once it gets in the bloodstream, it had the little pili adhere to everything. It's the leading cause. It was at one point the leading cause of pelvic inflammatory disease, early hysterectomies, ectopic pregnancies, infertility of an infectious disease nature. anytime a joint wouldn't be infected in an adult, gonorrhea. Just was. Just was. Rampant. Rampant. Acinetobacter is a very difficult one to deal with. It's interesting. This is every so often we go to war. eh, They saw a real uptick in this in infections in soldiers in the Gulf Storm, the Gulf War era. Even though it's something we see in this country, there was a real uptick in Acinetobacter. Campylobacter is a Campylobacter jejuni is an enteric problem that's particularly drug resistant. It's a really nasty form of food infections. Here's the fluconazole being resistant to candida. That's a big problem because we need to be able to, because we get it so frequent. And here's the versa. And then group A streptococcus, that's the Viridan streptococcus. We're going to comment on that in respiratory diseases. Group A is, I beg your pardon, is the strep pyogenes. Group B is the Viridans one, which we see problems one in selective basis that are there. So different ways that we're talking about it. RNA interference is kind of like what the COVID vaccine is an RNA, what's called an mRNA vaccine, shutting down the particular aspects of metabolism, different types of things. So we're starting to see that, again, Hep C and RSV that are there. And I don't want to give it short shift, so I think I'm going to stop. We're going to be done with this Wednesday. And when we conclude this ends the material for that exam. And then more information about the exam. And, I'll contemplate maybe by Friday doing the review. How's that sound? I'm so nice. Goodbye. Have fun storming it. Apologies. I just felt like I was just posturing today.